Hi guys, this is the second video in our series. This is another short video. I'm just going to explain the multiplication principle. So let's get to it. Let x and y be two finite sets. Correct. Then the number of ordered pairs x comma y satisfying x belongs to x and y belongs to capital Y set is simply mod of x multiplied by mod of y. So this is the basic multiplication principle. Here, what do we mean by ordered pairs? An ordered pair AB is a pair of numbers such that A belongs to one set and B belongs to another set. And clearly the first element always has to belong to the same set. So AB is not the same as BA, because BA would mean that B belongs to the first set and A belongs to the second set. So this is a different order, and these are two different ordered pairs. So if x and y are two finite sets and we want to create ordered pairs, then basically what we are doing is creating this Cartesian product. When you go to 11th standard, or if you are in 11th standard, you can look at NCERT and it has this Cartesian product of two sets. A Cartesian product is basically just a collection of all such ordered pairs, xy such that x belongs to x and y belongs to y, right? So basically what we are doing in multiplication principle is finding out how many elements are there in this Cartesian product. How many elements are there in this x cross y? So that is basically going to be number of elements in x multiplied by number of elements in y, right? So that is very straightforward. The reason will be obvious when we do a couple of questions. So let's do a very simple example first. So how many two-digit numbers are possible, right? How many two-digit numbers are there, right? So if you want to answer this question, think of these two numbers, and this two-digit number can be thought of as an ordered pair, right? The first digit comes from some set and the second digit comes from some other set, right? And first digit of this number has to come from what set? Has to come from the set 1 to 9, right? Because 0 cannot be part of that. The first digit comes from here and second digit comes from 0 to 9, right? Because 0 can be a part here. So the number of elements in this set are 9 and the number of elements in this set are 10. So 9 into 10 is the number of ordered pairs. So 90 such numbers should be there, right? And we know that 90 two-digit numbers are possible because 1 to 99 is total 99 and you can subtract 1 to 9 from there, right? That will give you the 92-digit numbers. So that was just a very trivial example. Let's look towards generalizing this multiplication principle, generalized multiplication principle. So here, what will we construct is a k tuple. So what do we mean by that? So let x1, x2, and xk be finite sets. Finite sets, number of elements is finite. Then the number of k tuples. K tuples means it is a collection of k terms or k elements where each element belongs to a specific set. So this is a k tuple where each xi belongs to the capital Xi. So what we want to do is count the number of k tuples that are possible. And just by generalizing multiplication principle, we can say that this will be equal to cardinality of each of the xi's, right? Product of that. I goes from 1 to n, right? So basically it is mod of x1, mod of x2, mod of x3 and multiplying till we come to mod of xk actually here, right? So that is the number of k tuples that are possible. So another simple question on this. So how many four-digit positive numbers are possible which start and end with even digits? Start and end with even digits, right? So again, when we had a 2-digit positive number, then we were constructing a ordered pair, right? Now we have 4-digit positive number, so we have to construct a 4 tuple. This is a 4 tuple. So each of the xi's has to come from a different set of numbers, right? So, I mean, they can be identical sets, but they are different sets from each other. So x1 clearly should be an even digit and it cannot be 0. So it should be 2, 4, 6, 8. X2 has no restriction. This is the middle 2 digits don't have any restrictions. So it can be anything from 0 to 9. X2 and X3 actually. And X4 has to be an even digit, but now it can use the number 0, right? So 0, 2, 4, 6, 8. So these are my x1, x2, x3, and x4. So the number of ways in which the k tuple can be constructed is basically going to be the multiplication of all of these, right? So mod of x1 multiplied by mod of x2 multiplied by mod of x3 multiplied by mod of x4, right? So that will be 4 into 5 into 10 square, right? Correct. So that is the answer for this, 4 into 10 into 10 into 5, right? One last question that we will discuss is the special case when each of the xi has the same size, when each xi has the same size. So this is the type of question that you will encounter when you say that if A is a finite alphabet, if A is a finite alphabet, then how many, then finite alphabet of size n, then how many k length strings are possible? K length strings are possible in that. Strings are possible. So what do we mean by this question? By finite alphabet, what we mean is, like, English alphabet has 26 letters, right? So n is 26 for the English alphabet. Similarly, Hindi will have a different number of letters in that alphabet. So A is any finite alphabet with size n, and how many k length strings are possible? So basically we are constructing a string of length k. So therefore we want a k tuple, right? X1, X2, X3, and Xk. And we are trying to find out how many such k tuples are possible. So obviously each of the capital Xi's here, capital Xi's, X1, X2, X3, the sets from which these numbers are supposed to be picked have equal size. Each of them have equal size. So n possibilities here, n possibilities here, and so on, and n possibilities here. And there are k such products. So when you multiply, it becomes n power k, right? So that is the number of strings that are possible in a finite alphabet of size n, right? So this is multiplication principle, and this is the generalized version of multiplication principle. What we will do going forward is apply addition and multiplication principle together in different problems and see how we will understand when to use addition and when to use multiplication. So I hope you understood this concept, and I'll see you next time with more videos on how to go ahead in this course.